Alright, so we're going to go over the first two steps here. So we're going to remove the unnecessary items out of our workspace and keep our direct compounding area free and clear, and that first air can get over our direct compounding area. So we want to remove unnecessary items out of our way. We're going to reconstitute the powdered vial with the bacteriostatics. We want that in our field, and we can move everything else out of the way. We're going to use a 5 cc syringe, so we'll keep that. We're not going to use the filter needle until later, and we'll use only one of the needles. Alright, so the first thing is that we're pretending this area here is our hood. So the laminar flow air is coming towards me, towards my chest, like this. So we don't want to place things like this in our hood. Alright, so we want to make first air available to this direct compounding area, and so we don't want to block it. This is actually an okay setup, because first air would come over here and only hit this area, which we don't really care about. This is our direct compounding area. This is our direct compounding area. And so in this setup, from a first air standpoint, it's okay. From the standpoint of trying to work like that, it's not okay, from the fact that it's awkward. Real simple to go like this, or to go like this, and we're now blocking first air to that area. So we want to try to put everything in parallel with the first air. So if this is our HEPA filter and the first air is coming this way, we want to set everything up so we're not blocking anything. Alright, so the first thing we're going to do is we're going to take off the caps like this. Now you'll notice that this has a little ring on it. That's going to be the second part of the exercise here. But for right now, we're going to keep the ring on like that. We're going to keep everything here. Now the next thing we're going to do is we're going to take an alcohol pad, and we're going to see I broke it, I ripped it here, not here where particles would come over our area, but I ripped it back here, closest to me, away from my direct compounding area and downwind of my direct compounding area. So we're going to wipe it off our areas that we're going to work on, and then we're going to allow the alcohol to dry. Now if you remember back from the lectures, alcohol has its antimicrobial activity by the fact that it will evaporate the water out of the microbe and basically make it shrivel up and die. And so we must allow the alcohol to completely evaporate to get the maximum antibacterial and disinfectant action of the alcohol. Alright, so I'm going to move that over here. Now, to open up a syringe, we have sort of like little pull handles here. Now, when we open up the syringe, we want to make sure that we open it up very carefully, very gently. We don't want to rip it open. That would create particles, get particles in our direct compounding area. So we want to open it up just enough. And as you can see, I'm going to put the trash over to the side. And as you can see, I am not blocking first air like this. I'm not touching this. You don't want to touch that area. And you want to make sure that this is free and clear. So you don't want to work like this behind something. You want to make sure it's up here. Now what we can do, this is called sterilely storing something. We, as far as the syringes are concerned, we put the syringe right here. And as you can see, it's not blocking first air of anything around it. First air is not being blocked. If we had a much larger, like say, container, this would be blocking first air. That would not be correct. We could do this. That's fine, because this is actually, well, actually it's a little higher, so it wouldn't be correct. If this was like this and this was higher, then that would be fine, just like I had mentioned before. But because this syringe is actually a little higher than this area, we're blocking first area to this direct compounding area. We're going to open up the needle the same way, just like this. It's called peel and present. Now, we could, if we wanted to, what's called pop the needle. And if you pop through, you're basically going like this and ripping it. Now what happens when you do that is that you rip it, all the particles and all the paper go right into this area right here. It goes right into the hub and drops all those particles right into to that area. Not good. So we want to always peel and present, and how you attach it, you peel and present, and you're in first air, and you want to connect it like this. Alright? Just like that. Now, we can sterilely store this by standing this up like this, or we could lay this down like this. Now, when we talk about hoods, I will explain that when we go into the clean room. Some hoods are okay to store things like this. You'll get good first air over the needle and the syringe, but some hoods are not, because they have a lip back here that actually creates eddies back here as well. So we don't want to do that in those types of hoods. Well, how do you know what kind of hood you have? Your employer, whoever you're working for, should be able to tell you, because they've done smoke studies. You should be able to say to them, I want to see the smoke studies for this particular hood because I want to know the characteristics of it. However, though, kind of the best way to do it is this way, because you know that this isn't first air. You know that there's no compromise. You don't have to really know a smoke study here, because this is way off the ground, and it's completely in first air. Alright, so we have our syringe, and we have our product here that we're going to withdraw from. Alright, first thing we do is we pull off the needle cap. Now, this is the bevel. Okay, the bevel is at a 45 degree, or it's at probably almost 160 degrees here. This is the heel of the bevel, and that's obviously the tip of the needle and also the bevel itself. So when we enter in the syringe, we're going to enter in at a 45 degree angle from the bevel to the top of the stopper. So 45 degree angle like this, go all the way down until the heel is all the way immersed into the stopper. Then you go you go 90 degrees, and then finish pushing the needle in. This way it doesn't core. If you went straight down, what can happen is that bevel, or that heel right there, as you're going straight down, can pull a piece of rubber from the stopper into your product. Now, these needles are pretty precise. Probably not going to happen, but I can tell you that it does happen every once in a while. I have seen product in here where there is a little piece of rubber core, so it does happen. Probably not every single time, and I couldn't give you a percentage, but it's a very, very small percentage. So to prevent that from happening every time, we want to go in at a 45 degree angle, just like this, go down. Once the bevel's passed, or the heel of the bevel's passed, then you go at a 90 degree angle. Okay, now, in order to hold this, you take your two fingers, you hold the neck of the bottle or the vial, and see, I got good holding power on that. And then with this hand here, I put one finger on the flange here of the barrel, and then the other two fingers here, like my pincer fingers here, I will hold on to the plunger. And I push back, I pull back, and I push up with my finger, and then I can pull back what I need. Now, you can see there's a whole bunch of bubbles in there. What I want to do is, this is something that you're going to have to learn. Hold the vial with these two fingers here. Take your pincer fingers and thumb and this finger here, and you're going to hold the barrel. Okay? From there, we can go and flick it, or we can go like this with our knuckle. Now, the important thing is that if there's bubbles on this side, you want to turn the barrel around and try to knock the bubbles off on the opposite side. Okay, and it should be very quick and very precise, kind of tapping. Okay, just like that. If you're going like this, that's never going to work. It's got to be one good tap, and it'll come off. Okay. Another way you can do this is that you can pull back a big bubble, try to consolidate any of the smaller bubbles on the side, right? And then we can push up the rest of the fluid there. Now, as I showed in the slides, when we measure, we're measuring from the bottom of the tip of the black plunger. Okay, we're not measuring at the top of the cone. We're measuring at the bottom of the bottom of the first ring, and that goes. Say we want 2.5. We actually want 2.25. So each one of these is 0.2, 0.2, 0.4, 0.6, 0.83. All right, so 2, and then so we want 0.25. All right, so we will go to 2.2, and then if you go half the distance, that's 0.5. Right? I mean 0.1, or 0.01, and so we want 0.05. So you would go about a quarter of the distance right there. So we would go to 2.2, and just a little bit beyond that gets you 2.25. Right? We withdraw the needle. Oops, don't drop it. We withdraw the needle. Then we can pull back, and there's a bubble still there. All right, so we can get that bubble off by turning it to the opposite side, tapping it, and then we pull back on the syringe just a little bit, because once we go like this, water or whatever fluid jumps back into the hub. And if I just push this like this, you can see the liquid's coming right out of the needle. So whenever we do anything like this, manipulate it, we want to pull back, pull that extra volume that's been shoved up into the hub, so that we can easily expel the air but not expel the fluid. Alright, so we slowly bring the fluid up into the hub and up into the needle. We want to do it right until we get a bubble right there, or a droplet right there. Then we pull back just a little bit so it goes back into the needle. Alright, so that's the first two steps of this. Actually, I'm sorry. Nope. I was just reading the directions. We're going to put this in there first. Alright, the same way, so we're going to reconstitute this vial. So we go in at a 45-degree angle till the hub of the bevel is covered, and then go straight down. And here, we're just going to inject the water. Now we're going to pull back some air out of here, so we have a negative pressure in here. We have a negative pressure. If you listen really closely, you can hear that kind of sucking sound from the vial. That means we definitely have a negative pressure in there, and then all the fluid will stay into the vial. And if we had a real high positive pressure, all the fluid, as soon as you take the needle out, is going to try to spew out, and you don't want that. Alright? And if you really look close at this video, when I pulled the needle out of here, because I was manipulating it so much and I was putting air back into the system, when I pulled it back out, I don't know if you caught that, but that was overpressurization, and a stream of water came out, or in this case sodium chloride came out onto the desk. We don't want that, but for purposes of demonstration, I had overpressurized this vial. So we want to pull back, negatively pressurize that one. Now, this is where I was talking about aseptically storing it. So we're going to put the syringe and the needle like this. Okay, we don't want to recap it. We don't have to, because it's going to be in first air. Okay, so here we're going to shake it up until it gets all into solution. And it's okay if it doesn't get all into solution. This isn't a protein, so you can shake it really hard. It's not going to be an issue. This is just sodium chloride, it's just salt in there. So try to get it in solution as much as possible. It's not going to go completely into solution. As you can see, it's kind of cloudy. It's kind of a super saturated solution at this point in time. And that's it. So we're going to go to the next couple steps. All right.